So what's the definition of a derivative? A derivative is the slope of x, and also can be defined as the different quotient, which is the limit as h go to 0, and then of x plus h minus of x over h. This is the definition of a derivative. Let's jump now to a linear function. So let's say we have a linear function as f of x is equal to 4x plus 2. This is just a line. Basically, when we draw it, should be something like this. We have a positive slope of 4. Okay. So, what we have in here is that as we define the derivative as a slope, what is the slope here? The slope is just 4, and that should be our derivative. Why? Because when we use the linear formula, which is m of x plus b, where m is the slope. That's why 4 is the slope here. But let's try to use the definition of the derivative. Apply it here. So f of x will be the limit as h goes to 0 of x plus h minus f of x, and then over h. Let's find first f of x plus h, this term here. When we take this function, what's gonna be is that of 4, and then x here as x plus h, and then plus 2. That's our function here, but we substitute x with x plus h. When we expand, here will be 4x plus 4h plus b. Now, let's take this formula. Of x is equal to limit of x of h goes to 0, and then we will substitute this term with this term in here, which is 4x plus 4h plus 2, and then here minus our function in here, 4x plus 2, and then over h. Let's expand. So that will be the limit of h goes to 0, 4x plus 4h plus 2 minus 4x, then minus 2, then over h. Let's simplify. Negative 2 and positive 2 will go, and then 4x minus 4x and 4x will go, and what we left from the top is plus 4x, so that will be the limit as h goes to 0 of 4h over h, which will be just 4, which is the same conclusion as this one in here. Now, let's give a general form of a derivative of a linear function. So let's say f of x is equal to mx plus b, and we want to find the derivative of that function. To do that, we know that it's just the slope and should be m, or what we can do is use the different quotient, which is limit as h goes to 0 as f of x plus h minus f of x over h. this term as f of x plus h. Plug it in here. That will be m, and then x plus h plus b. We expand mx, and then plus mh plus b. Now we go back here. So f of x will be the limit. H goes to 0. And then we can substitute this term by this. So that will be m of x plus mh plus b. And then minus this. It will expand, so that will be negative, since we have a negative here. So that will be m of x minus b. And then over h. So this term, positive b and negative b, will go, and then negative mx with positive mx with positive mx will go. This term will stay. Okay, so that will be limit as h goes to 0 as this term here, which is what's left, over h. This is h. So what does that mean? So what we left is just an m, and that is the derivative of a linear function.